This is the absolute value equation solutions. We have an absolute value equation. And when you read this, we see that the absolute value of x is 6. Now this means two things. It means in one case, x is positive 6, and in another case, x is negative 6. It is the opposite. I'll take some time to briefly describe what this means. Notice when I place x with a positive 6 in my absolute value, the absolute value of positive 6 is 6. Similarly, if I place a negative 6 in my absolute value for x, I get the absolute value of negative 6 also being 6. This is why we have two answers. When we list these solutions, or answers, we have a solution set. This is what you should see. Number 3. The absolute value of x minus 1 is positive 8. Again, we have two solutions. Between my absolute value sign, I have x minus 1, and that means that in one case, x minus 1 is positive 8, and in the other case, x minus 1 is negative 8. Notice, in both cases, if I replace x minus 1 with the value positive 8, or if I replace x minus 1 with the value negative 8, in both cases, the absolute value is positive 8. I am now going to solve each equation for x. Adding 1 to both sides for both equations gives me x equals 9. It gives me x equals negative 7. These are my solutions. Positive 9, negative 7. This is the solution set. Number 5. The absolute value of 7x minus 2 equals 5. Again, we'll have two solutions. Notice between the absolute value sign is 7x minus 2. So in the first case, 7x minus 2 is positive 5. In the second case, 7x minus 2 is opposite positive 5, which is negative 5. Notice, if I replace 7x minus 2 with a positive 5 or a negative 5, in both cases, the absolute value is positive 5. We are now going to solve these equations. Add 2 to both sides for each equation. We end up getting 7x equals 7, or 7x equals negative 3. Divide both by 7, and here's what you get. X equals 1, or x equals negative 3 over 7. As a solution set, we could describe this as 1 comma negative 3 over 7. Number 7. We have the absolute value of 3x equals 24. Again, we're going to have two solutions. Notice, 3x is between my absolute value sign. So I'm going to say 3x is, in one case, positive 24. 3x is, in another case, negative 24. I'm going to replace 3x with positive 24 and negative 24. Notice, in both cases, the absolute value is positive 24. We're now going to solve both of these equations. Divide both sides here by 3. We get x equals 24 divided by 3 is positive 8, or x equals negative 8. These are my two solutions that I will place in the solution set. Number 9. The absolute value of 5x plus 4 equals 10. I don't have the absolute value by itself, so I need to solve for that absolute value by using my skills in algebra. We're going to subtract 4 from both sides. We're going to end up with 5x equals 10 minus 4, which is 6. We have just solved for the absolute value. Again, we'll have two solutions. In one case, 5x is positive 6. The other case, 5x is negative 6. Notice, if I replace 5x with positive 6 or negative 6, the absolute value of both is a positive 6. We're going to divide both sides for both equations by 5 to solve for x. X equals 6/5, or x equals minus 6/5. Your solution set is 6/5, comma, negative 6/5. Number 11. We get 6 times the absolute value of x plus 5 equals 12. We're going to have to solve for the absolute value. In this case, it's the absolute value of x. I'm going to start by subtracting 5 from both sides and using algebra. We get 6 times the absolute value of x is 12 minus 5, which is 7. We divide both sides by 6, so we can cancel. We obtain the absolute value of x is 7/6. Again, we get two solutions. In one case, x is positive 7/6. The other case, x is negative 7/6. These are my solutions. Number 13. the absolute value of 5x plus 2 divided by 3 equals 3. Again, we're going to have two solutions. Notice in my absolute value, I have a ratio of 5x plus 2 over 3. So that means in one case, that ratio equals positive 3. It means in the other case, that ratio equals negative 3. Notice, if I replace the ratio with positive 3 or negative 3, the absolute value for both is 3 again. We're going to solve this ratio here by multiplying both sides by 3 for both equations, so that my 3's cancel. Here's what we get. 5x plus 2 is positive 9. 5x plus 2 is negative 9. I'm going to subtract 2 from both sides. 5x is 7. 5x is negative 11. We get x is 7/5, or x is negative 11/5. These are my solutions. 7/5, negative 11/5. Number 15. The absolute value of 2x minus 9 is negative 4. No solution. And here's the reason. Very often, people make the mistake and think that if I just replace what's between my absolute value sign with either a positive 4 or a negative 4, this is our general approach. Not exactly. If you notice that the absolute value of 4 is actually positive 4, and the absolute value of negative 4 is positive 4, both of these are not equal to the negative 4. In other words, there are no values of x that I can place inside this absolute value that will give me a negative number, because the absolute value of anything is usually positive. I say usually positive because there is one exception. That's the absolute value of 0. The absolute value of 0 is 0. We could never get the absolute value equal to a negative. This is why there's no solution. The solution set is empty. Number 17. The absolute value of 5s minus 8 is equal to s plus 6. We have two solutions. Consider the following. Either 5s minus 8 is the same as s plus 6, or 5s minus 8 is opposite the s plus 6. To emphasize this, either they are the same or they are opposites. Opposite in sign. So when we go solve each equation, we'll add 8 to both sides. Don't forget in the second equation to use a distributive property, meaning we'll get 5s minus 8 equal to negative s minus 6. In this case, we get 5s equals s plus 14. In the second equation, we can add 8. We'll end up with 5s equals negative s plus 2. We still continue to solve these equations. Subtract s from both sides, add s to both sides. We get 4s equal to 14. Here we get 6s equal to 2. Divide both sides here by 4. Divide both sides here by 6. So we can cancel. S equals 14 fourths, which reduces to 7 halves. Here, S equals 1/3. 2/6 reduces to 1/3. The answers in our solution set are 7 halves and 1/3. Number 19. The absolute value of y minus 5 equals the absolute value of 5 minus y. Again, we have two solutions. In one case, y minus 5 is 5 minus y. In the other case, y minus 5 is opposite 5 minus y. They are either the same or they are what? Opposites. Let's not forget to distribute. Let's solve both of these equations. I'm going to add 5 to both sides. For the first equation, I get y equals 10 minus y. If I solve that first equation, let me add y to both sides, and I end up with 2y equals 10. If I divide both sides now by 2, I obtain y equal to 5. We're going to work on the second equation. Y minus 5 is negative 5 plus y when I distribute. I'm now going to add 5 to both sides, and I end up with the statement that y equals y. Now this is an identity. This is a very important identity that simply says that y can be any number. Y can be any value. Y can be 2. I can replace my Y here with a 2. I get a true statement. I can replace it with a -3. It's equal to -3. I can replace it with a 0. It's equal to itself, 0. What we say here, your solution can be any real number. So if I add 5 to the real number list, because this is OR, our final answer in set notation, or I should say in set logic, set information, is all real numbers. Any real number will work here as a solution. And it's all because we have a true statement here. We have an identity. All real numbers.